Gerardo is getting hooked up here. So while we have a little bit of time, I'll introduce him. He's a CTO and I guess CISO as well of Satellogic, and runs labs and teams to build cutting edge technology for over 25 years. And let's see, anything. Worked at a lot of 3-letter and 4-letter agencies, it looks like. So glad to have you here to talk about this secure operations of a constellation as a service platform. Take it away.
Thank you.
Oh,
Okay, thank you. So first, let me introduce what we do, what I do, because I'm going to talk about our sort of threat landscape. Satellogic is a company that actually yesterday was the 10th birthday of our first launch. It's 13 years old. I didn't know. Somebody just told me. So, we got 30 operational satellites plus 4 that we are commissioning. We launched 10 days ago. Our satellites are Earth observation satellites doing imagery below the meter. With this capacity, we can do up to today 7 recaptures of particular places. I mean, selected 7 recaptures of places in the ground, not all the Earth, right? 7 times, but if we pick a place, we can do it. And we also have some onboard processing capacity, which I'm going to talk about. And we are still launching, growing our constellation until we get to our first goal of doing weekly revisit of the whole Earth, right? Myself, before doing Satellogic, I was doing security for 15 years, pretty much intrusive red teaming, it's called today, security, offensive, and then I moved into doing satellites. So what we do, we offer space systems to our customers. That's satellites. Some customers just want satellites, and since we are launching so often, we can deliver a satellite. If we come today, maybe in 3-6 months, right, in orbit. And this presents some challenges in terms of security. We also have a constellation as a service product line, which is for particular customers. They want to make sure they have capacity over an area of the world, so they buy sort of a portion of our constellation there, which leads to a shared infrastructure in orbit, right? Brings some security challenges. And then we do a more traditional asset monitoring imagery product line, where we sell images to our customers, and they also have some security, integrity, authenticity requirements. And so I'm going to try to answer all those things here. So what usually, more traditionally, when people think about satellite security, communication security. All right, we do some of that. So this is important, right? Security is a whole. You cannot just do one thing and pretend you are secure. So you need to address all you can imagine, pretty much. So we don't want anybody building their own ground stations and talking to our satellites. Or we don't want a bored teenager sitting at the ground station and talking to our satellites, right? In the North Pole or the South Pole. I don't imply it might happen, really. But I mean, we don't have to trust the operations, the operators of the ground stations, really. We shouldn't need to trust it. So what we do, we use crypto. Pretty much, we have public keys, private keys all around, and the traffic through the ground stations should mean nothing but random. All right? So it has to be end-to-end. We cannot re-encrypt at the ground station. That's a weak spot. And we use existing protocols, existing algorithms complying with recommendations of NIST and certified libraries, FIPS, actually Wolf SSL out there. That's a good option. I don't get a discount or anything. And we do TLS 1.3. We don't have self-signed certificates. We have a trust chain that you can trust, and we chose our algorithms to be compatible with the hardware and with the standards. As I said, the ground stations are just a sort of bend pipe, all going through. Should mean nothing to anybody seeing it. We use private keys and certificates for authentication, for both authenticating the ground stations, actually not the ground stations, my mistake, but the operation center, right? Ground stations don't have any crypto, material. So we authenticate the operation system center to the satellites and the satellites back. And we also use them to do integrity and authenticity checks on the data that we download, on the imagery we download, all right? And on what we upload, updates that we do quite often, right? And configurations, software updates every week. Not everybody with the key, with the right certificate, with the right trust chain can do anything on the satellite. There is some sort of authentication, authorization, I wouldn't dare to say airbag, but all right. Like not anybody can do anything, even if they have a key. We have TPMs on board. We use HSMs in the ground, and we have a firewall at the border of the satellite that doesn't allow any unencrypted traffic to go in, unencrypted, unauthenticated, and integrity checked. All right. Security is a process, right? You're never done. So if I say this is what we have implemented is perfect, you shouldn't trust me, all right? There's always more things to do, and everything here has a new version upcoming, so nothing is ever done, right? But we have that. And then the next thing people usually think about satellite security is the device, the satellite as a device. What can we do there? We protect the internal domain with the firewall, as I said. We also have internal security domains in hardware and software, especially because we do hosted payloads for some customers where they send to us their hardware, we integrate it and test it, and we isolate it. I swear we do. Yeah. So it's there, isolated. And we also run algorithms for some customers that do machine learning on the images. And we have, for that we use containers, pretty much. It also runs on a hardware that's separated, and when they need to talk to the few services they need to talk, they do it through APIs, right? Inside the satellite. And we do regular software updates, not so regular firmware updates, maybe every 2-3 months. I've been saying lately. This allows us to update software, fix things, and it's also risk, right? So we have a mechanism to only allow updates into the satellite that are properly signed, for example. All right. We download logs from the systems in the satellites, and we started integrating them into the SIEM of the company, right? Because some of the systems in the satellites are actually Linuxes, and some are not, right? And so some things are easier to integrate into the SIEM, and yeah, we're doing more in the future there, and we are not actually. I didn't do any of the questions, and I didn't change my slides, but we are starting on thinking on doing onboard detection of anomalies. All right, that was the question on the previous talk. Yeah, and people want to know, right? Yeah. So then I said security is a system, right? Say we do very well all the rest, but then somebody gets into our operators' computers, and through that into the satellites. It can never happen, right? Not in Ukraine, not in anywhere, right? That's exactly what happened. So we do what every tech company does in terms of security, I hope. we implement a single source of identity, we do MFA and context aware, and actually we're moving into continuous evaluation of identities. We have deployed zero trust network, moving further into micro-segmentation. We have everything is ongoing, but we are still implementing our least privileged access big scheme, right? And we do our incident detection and response, our CM, where we integrate satellite and ground station data. We work with the developers on their software development life cycle, implementing static checks, dynamic checks, and software bombs and configuration checks. And we have an internal awareness program for everybody, and we do detect phishing attempts and a few directed phishing attempts there. So it kind of works. And this is just an introduction, because I really want to talk about what we do for constellation as a service, especially, and then satellite system. This is kind of the timer is not running, but I guess I'm fine. And kind of a drawing of the system, right, where this user down there has its own private constellation, sub-constellation, right? So what we do for some customers, we can give them their own set of private keys, and all satellites private keys with the certificates and trust chain and all, so they can privately talk to the satellites without even us knowing what they do. We don't really allow them to do low-level things. We only allow them to operate the satellites in the payload, pretty much, capture opportunities. So these customers have the opportunity to do what we call private tasking. They have their own planner of the operation of the constellation. They plan the opportunities, they capture opportunities, they encrypt the plan and send it encrypted to the satellite. So not even our operators can see what they're doing. All right. They do give us some metadata that allows us to control if they have gone over their quota, for example, right? But it's something that we agree with the customer they can share. Usually they are okay with that. And then the satellite merges plans from different customers and executes it only in the satellite, all right? So they also do their own on-premises data processing. They can. I mean, all things are optional. Different customers are different, right? But they can do their on-premises processing, and as a sort of resilience, they have the whole constellation available if they need more ground station or more the whole network, right? More ground station time, or more capture opportunities for a particular situation, or to back up a satellite. All right. But then there's the path back to the customer, because if an operator sees the images they capture, they will know where they capture the image. So the satellites encrypt the data, the results, to the customer's private key. So the customer can benefit from our ground station network, being sure that nobody without the private key, their private key, can see the results. All right. So this, of course, we force them to make their own processing, because otherwise we would be seeing the data, right? But that's fine. We package some processing modules, and together with the encryption, the satellite actually, the camera system signs the data, so the customer can be sure the data is actually coming from the satellite with its TPM, all right, module, hardware support. And then, yeah, well, they have to do their own data processing. All this integrity and authenticity validation could be done by any customer, right? Because the only thing the customer needs, not only constellation as a service, the only thing the customer needs is the public key of the satellites to verify that the signature is correct. And the public key is a public key, right? But then the customer will buy from us processed information, not the raw data coming from the satellite. So in that sense, what we can do, we don't have a customer using it, so it's can do. It's provide them with the raw data with the proper signature, so they can. It's easy visually with our data to see that the further processed data matches the raw data. Just visually, you can see it. You can build the pipeline to do it, right? So not only the constellation as a service customers can benefit from authenticity and integrity checks, but eventually any interest customer that's just buying images from us could do it, right? And then we also offer space systems, satellite systems, to a customer that wants to actually have full ownership of the satellite, maybe operate a satellite or get us to do some of the maintenance operation, but otherwise operate it with their own ground stations. Yeah, this is, some people see it as a plus for security, full ownership, right? Like sovereignty, and even for customers who buy not a system but a constellation, they can have control on the supply chain, right? It's not satellite technology. It's, I don't know, supply chain technology, but we can do it we do it actually for customers. It gives them operational independence, and then on-premises ground station, which is also something some customers believe will protect their communications, though I believe you don't protect your communications with guns, you protect it with crypto, right? But still, that's fine. And then as resiliency, we can launch again in 3-6 months if needed, but otherwise we have the whole constellation for somebody to use as a backup, all right, if needed. With not, in my crypto point of view, not so much of a loss on security, data security at least. And I think I went too fast, but this is it, all right? I have no idea.
No, it's good. It actually gives us more time for some questions. I had a question that I wrote. I think you answered, but so from a satellite as a service or constellation as a service perspective, you have two options. One would be to utilize your ground infrastructure, and they send, I guess, data through you up and utilize your ground. And then the other one is you can just buy a satellite basically and control it yourself. Is that,
Yeah.
that true? Okay.
Yeah, that's right.
Good.
Yeah.
Any questions in the room before I go online to pick some here?
Or get a mix, right?
Yeah, I'll get a mix. Who was that? You?
Hello, it's Mark here from Thales. So I saw that you have been using a lot of asymmetric encryption and the key exchanges. How do you protect from the quantum threat? Have you already thought about it?
Yes. First, we don't consider our information today sensitive to store and decrypt later attacks. Our images lose value with time, really. But that's my point of view and the existing customer's point of view. So it might change, all right? And then, in my opinion, the best protection we have is that we use libraries that are updated very often. Actually, I just learned that there is a post-quantum version of some algorithms. But then, the most basic protection, in my opinion, is that we can and do update the software regularly. And our satellites can be operated for no longer. They are designed for 3 to 4 years lifetime. So we don't only update. We didn't have TPMs in the previous version, for example. And we changed the whole camera system too in the next version to be launched, right? So in my opinion, the best protection is our dynamism in both in software and hardware. Because as far as I know, attacks are not still there today, right?
Question from online is, on the encryption, do you use symmetric or asymmetric encryption on the satellites X509 in space?
Yes, it's X509 in space. We do both. You cannot do just asymmetric, really. But we do both. We do TLS 1.3 with elliptic curves, so that's DSA and EC Diffie-Hellman 2 for key exchange and identification, authentication, and then we use AES for CBC and GCM for encryption of data, both for TT&C and data up and down. Yeah.
Yeah. So there was actually a question on TLS. You seemed like you got that one.
Yeah. 1.3. Yes.
Let's move on.
No TCP. No
TCP.
No TCP.
All right, I'll throw this question up while we have this gentleman here. So, you mentioned segmentation on the satellite. So, I guess from your main CNDH bus to the payloads, can you explain kind of how that segmentation approach works?
Yes. It's not even IP. Yes. I actually said segmentation. Yes, on the payloads, on what I call hosted payload, which is third-party payloads. It's hardware or software hosted payload. We have more than one network inside the satellite. There's one network with the bus, with the main payload, the camera system, and the secondary payload, the other camera system. And then there's a network to talk to a firewall router, I don't know, something that's between the bus and the network for the hosted payloads, all right? So this thing isolates and only you can only talk in and out through APIs on this thing in the middle. Furthermore, we turn off the media support for the comms networks inside the hosted payload domain, while the hosted payload is operating. And then for just software, we do containers, and we turn off the networking of the containers and do some hardening, right? Then it's regular security. I hope that answers the question.
Great. I also had a question about, sorry, over here, about the keys for the cryptography. One thing I've noticed that seems to be blocking a lot of production and rollout of cryptography in satellite systems is a kind of telecommand recovery procedure, where if like the key is compromised or leaked somehow, as has happened to, I don't know, several Korean government satellites.
Yes.
Like you need to be able to recover from that, otherwise your space asset is just junk. So have you, what sort of protocol have you guys put in place for that?
My VP of security is getting a plus. He told me to put in the slide, but I said no, that's too much. So we have what we call a hard command scheme, which with one-time passwords to disable crypto, all right? And a few other very basic things like reset the satellite. So only I know where these things are stored in the HSM, and only I can. I'm CISO, right? And CTO is I'm a co-founder. Like it's really me. It's am I in danger? So who can unlock one of these one-time keys? All right. Then yes, there's a race. There's a race condition. There's a window where the satellite will be not dead, but available, right? We hope to close it. But you actually ask about the procedure. It's on the same communication. It's send the one-time key, and then reestablish the trust chain. All right, and we can how do you say it? Make certificate for invalidate keys. I don't know. There's a term for that.
Revoke?
Yes, we can do revocations. Yes.
Great, thank you.
Thanks.
Yeah, that was actually a question that was someone else put up, as how do you do key revocation? It sounds like you have a process for that.
Yeah, I can answer that. We do our own. We do our own we do our own certifications for our keys, but the trust chain goes to VeriSign. All right. So VeriSign is not involved in issuing keys for the satellites, but you can check that our root CA key is actually valid, and then with that check the satellites keys. Well, not you, but our customers.
All right,
Some of our customers who are so sensitive.
Is there any last questions in the room before we go to a coffee break, or any more? There's still maybe let me see if I can get one more question here. Yeah, we'll do one more and then a coffee break, because I like this question. So do you have the ability to detect malicious code sent by a user to a satellite? So I guess, do you have any onboard monitoring capabilities on the vehicle?
We haven't deployed. We have the ability if the malicious code kills the satellite. But no, we don't have any.
So this will be like in the instance where you're, I guess, leasing out a space system per se, right? So
Yes,
I guess in both scenarios, right?
No. Well, I've mentioned it before. We haven't deployed any of this. We are working on it. All right. It's not trivial. We do some FDIR on other system levels, and that's where we think we could plug this, right? But
right. So to be determined.
We have some mechanisms to detect in the ground, right?
Right.
Like if we detect asymmetries in how many commands the satellite received versus what we know we sent, for example, valid or invalid commands, we can detect things in the ground, right?
Right. Okay. Well, that concludes this session. I think 3:30. It's time for coffee and stretching your legs. Thank you for your attention and time.
Thank you. I hope
Come back in 30 minutes.
enjoyed it.